Welcome to ITHACA. In this video, I will walk through the third exercise in the Quick Start Guide. The Quick Start Guide comes with every installation of the application and can also be downloaded from our website. This exercise uses the chlorine gas scrubber unit operation developed in Exercise 2 to build a simple flue gas scrubbing circuit. We will simulate startup of the column with a variable flue gas chlorine concentration. First, open a new project and save it. Then, link it to the database we created previously. Now we'll add all of the phases and components in the database to our current model. From our library created in Exercise 2, we now add the scrubber unit operation. The scrubber is currently empty of all material components, so we will fill it with inert gas to simulate an empty column containing just air. First, we pressurize one of the stages to atmospheric pressure with nitrogen. Then we copy its properties and paste them into the other four stages. Now we'll add a scrub solution tank. And we'll also fill it to the overflow with 10 gram per litre sodium hydroxide solution. Next, we'll add a water makeup stream to the tank. And now a reagent makeup stream. This stream will control the caustic concentration in the scrub tank, so we'll now set up a PI controller to control its flow rate. The process variable will be caustic concentration in the tank. The set point will be 10 grams per litre, and this needs to be a reverse acting controller. Now we'll add a solution bleed stream to the tank to control chlorine buildup in scrub solution. Next, we connect the scrub solution tank to the column. For this, we'll use a controlled stream and a constant flow rate. Now we connect the column solution discharge port to the scrub tank. Also required is a clean off-gas stream going to atmosphere. And finally, we need to add a flue gas stream. We will develop a gas composition that varies randomly within a probability density envelope, as is often seen in real processes. First, we add a combiner, 2 inlet streams, and an outlet stream connecting to the column. Next, we add 2 expression elements and a timer element to the flow sheet. We now set up one of the expression elements to generate a probabilistically sampled value. To do this, we open the menu, select the Stochastic Radio button, and go to the Stochastic Setup tab. For this example, we'll select inverse gamma as the probability distribution for this. We'll apply values of 6 and 1 for the shape and scale parameters, respectively. We now want to limit the upper value of the stochastically generated number to 1, to a maximum of 1, so that we can use the value as a weight fraction input. We'll use the remaining expression element and the min function to do this. We'll now set up a timer to trigger the gas concentration sampling event every 10 minutes. Now we'll apply our weight fraction value to the chlorine gas mixer. First we set one of the input streams to 100% chlorine gas and the other to 100% inert gas. Then we set up flow control. Initially, we want flue gas flow to be 0 until the scrub solution has had time to flow through the whole column. To simulate this delay in onset of flue gas flow, we'll leave the initial mode of flow as 0 and then create a second non-zero mode of flow for both streams. To do this, we choose the chlorine gas stream and add a second flow control mode. Then we specify a flow value for the second mode. This value will be a reference to the bounded stochastic value expression element. Now we specify a time for this stream to change its flow control mode from mode 1 to mode 2. We do that by adding a condition testing object to mode 1, selecting mode 2 as the new mode, adding a parameter to check the condition of, in this case, time, and a value of time for when this mode change should occur. In this case, we'll use 1 hour. We'll now also add an additional action that will be carried out after the mode change is made. This action will be to turn on the inert gas stream at the same time. Next, we add a second flow control mode to the inert gas stream. And specify a value for its flow. Finally, I'll add some monitoring charts. Now we're ready to run a simulation. Scrub solution enters the top of the column and flows through with no gas addition for the first hour. At the 1 hour mark, flue gas flow is turned on and chlorine immediately registers in both the scrub solution and then shortly afterwards in the clean off gas. Note the variability of clean off-gas chlorine concentration. That concludes the third quick start exercise. I hope you found this video helpful.